Hello and welcome to lesson 2-5. It's titled It's All Relative. This can be found on page 213 of your textbook. And we are going to be learning today about interpreting relative change or percent of error. So one of the first things we'll look at is one of my favorite quotes by Albert Einstein. When you sit with a nice girl for 2 hours, you think it's only a minute. But when you sit on a hot stove for a minute, you think it's 2 hours. That's relativity. Shows that relativity means that what's significant and what's not. In the paragraph below this quote, they give us a nice example. If I owe you $20, but I decide I'm only going to give you 10, does that work for you? How about if you win $5 million and now we short you $10 and only give you $4,999,990? Probably not going to be too upset by that. So the classwork starts towards the bottom of this page, and they do start us off with 2 purple boxes. The first purple box is the actual change, and that's the $10 in both cases, negative $10. So whether I owe you 20 and give you 10, or whether I owe you 5 million and give you 4,999,990, in both cases you are short $10. Negative $10 is the actual change. What shows us how important that is the relative change. So we take that actual change that we found and then divide it by the original value. Shows us how important it is. So on page 214, they work out the example showing us how that would work with me owing you $20 and me saying, I'm only gonna give you $10 and see if you're okay with that. So I owed you 20, I gave you 10, I shorted you $10. My actual change was negative 10. To find the relative change, we divide that by how much I was supposed to give you, which was $20. So negative 10 divided by 20 is negative 1/2. Or negative 50%. So you are shorted a significant amount of money. Let's do the same thing with the other example. You were owed $5 million, but you only got $4,999,990. So once again, you are shorted $10. That's the actual change. The actual change is the same as it was in the last problem with the $20. But this time we have to divide that actual change by what you were owed. You were owed 5 million. We can reduce that fraction a little bit. One technique we have for reducing fractions, especially when I have zeros, is that I can cross off the same number of zeros on the top and on the bottom. So this problem will simplify to negative 1 over 500,000. Which is a lot less significant than negative 1/2 that we had in the previous case. So it shows why it doesn't matter as much when we are shorted $10 out of a very large number. So number 2 says, compare those answers we just got, and is it what we kind of thought we were going to get? So in scenario 1, we were shorted negative 1/2 or negative 50%. In scenario 2, we were shorted negative 1 out of 500,000, which is much less significant than negative 1/2. So it's kind of what we predicted when we even read the original paragraph. Now we've actually got numbers to back it up. In number 3, our instructor tells us that we're going to get an additional 2 points on either a quiz or a test. Which would you want it on? Which would it have better value, and where would it not help as much? So let's kind of talk about the situation here. Our quizzes in here are worth 15 points. So adding 2 points to 15 would be significant. I can not spell today. Our tests in here are worth 100 points. So adding 2 points would not be as significant. So the lower the value of the item, the more adding a few points on will actually benefit the grade. Moving on to page 215. They're giving me some sentences and they want me to understand and explain what those sentences mean. They give me the example from that change of $20 being owed and only getting 10. So they said the relative change from $20 owed 10 was negative 1/2. That means the amount paid was by about a half of what it was supposed to be. So we want to understand what it means when they say the relative change in my budget was 7% compared to last year. That means that this year's budget is 7% higher than last year's. Let's do the same thing for number 5. Number 5 says the relative change in enrollment for this year compared to last year at my college was negative 3.5%. That means that this year's enrollment is 3.5% less than last year. In the next two, number 6 and 7, we're kind of going to reverse what we just did. It says for questions 6 and 7, write a statement using the term relative change or percent change to describe the information provided. It's pretty much the opposite of what we just finished doing. So in number 6, it says Apple's profit in 2020 was 3.9% higher than it was in 2019. So to use this in terms of relative or percent change, we would say the relative change in profit, the relative change in profit from 2019 to 2020 was 3.9%. Number 7, same idea, but this time we have a loss. So number 7 says the value of an investment was 5.5% less at the end of this year than it was at the end of last year. So we're going to start out again, the relative change in the investment compared to the previous year was negative 5.5%. So 4 and 5 and 6 and 7 are kind of opposites of each other, writing this in different ways. Towards the bottom of page 215, it's talking about how one interesting aspect of percent change is that it can be manipulated to make change seem bigger or smaller, depending on the perspective. So number 8 says, one of many businesses struggled during the COVID-19 pandemic. One business that had 150 employees had to let 60 of them go. We want to find what that percent change is in the number of employees. So we want to figure out what our actual change was. So how many people did I have after we let those people go? Well, that's the first thing I have to figure out is I went from 150 employees to 60, and I let go of 60 of them, so I now have 90 employees. So I'm going to take 90, that's my ending number, minus the original, which was 150. That will give me my actual change, and that agrees with what we just said. We are letting go of 60 people. But then to find the relative change, I have to divide that by the starting number, which was 150. I can use that same technique of crossing off zeros to make my fraction a little bit nicer before I drag out my calculator. And it's going to be negative something. I can pull out my calculator at this point and do, after I get to turn on, it always takes a moment to turn on. We can take negative 6 divided by 15. And and I get negative 0.4. So that means we let go 40%. 40% of my workforce was let go. It's negative because we're decreasing how many people we have. At the top of the next page, on page 216, they tell me what happened as the economy started recovering. As the economy started to recover, the same company hired 60 more workers and publicized the fact that they increased their workforce by 67%, which sounds weird because they just decreased by 40 and hired the same people back and increased by 60. Let's see where 67%, let's see where we're getting those numbers. So once I've hired those 60 back, I have 150 people minus the 90 that I started with at the beginning of the recovery. That tells me that I hired 60 people, so that's the actual change. And then on the bottom, we have to divide by how many we had. Well, when I started the recovery, I only had 90 employees before hiring new ones. So again, we can do some of this by hand, crossing off the zeros, and then we can pull out the calculator and do 6 divided by 9. So 6 divided by 9. And I get about 67%, 0.666 repeating, so that's about 67%. So they were indeed telling the truth, it's just because they're basing it on a smaller number of employees. Switching gears a little bit, we're going to talk a little bit about estimation. You've already been estimating in this course. Anytime you read a graph, you're estimating. So estimation is a skill that comes in very handy, and we're going to get some practice doing that. About the middle of this page, there's a nice timeline that's used in advances in medical science. And it's kind of good to get to know what it's saying first. I look at this timeline, it starts in 1500, that's the year. It ends in year 2100. And they've got some different discoveries. They've got the microscope invented, the discovery of bacteria, first vaccine developed, germs identified as the cause of disease, x-rays, and so on. You can read that all the way through. You notice as we get more and more current, there's more and more things that have happened medically. So number 10 wants us to estimate the year that the microscope was invented. So I see that that's right here. I see that it's a little bit before 1600. I see it's definitely after 1550. So I need to make a guess. My guess would probably be about 1590. And I just wrote that wrong. 1590. So I would guess the microscope was invented in about 1590. And I did that by estimating, but I used an educated guess. I knew it wasn't greater than the year 1600. I knew it was beyond 1550. I knew it was pretty close to 1600. So if you said 1580, 1595, 1591, there's lots of numbers you can guess that would be pretty accurate and pretty close. Number 11 wants us to estimate the year that germs were first identified as the cause of disease. So I have to find that first and find out where it crosses the timeline. It is between 1800 and 1900. More specifically, it's between 1850 and 1900, and it's pretty close to the 1850 mark. So my guess for this one might be around 1860, 1870, 1865. Those would all be valid answers. Let's go with 1860. Number 12 asks, we'll do this in a different color yet, which came first, the test tube baby or the first heart transplant? Let's go back up here. Here's my heart transplant. Just down there. It's between 1950 and 2000. And it looks like it's pretty close to 1970-ish. Let's write that in there. First test tube baby is after that, so it's definitely going to be later. We might say 1980. And again, it's a rough estimate. So we know that which one came first. The heart transplant came first. We estimated that to be around 1970. And we estimated the first test tube baby to be around 1980. Let's get yet a different color out. Which happened first? Organs grown from stem cells or the identification of HIV? Go back to our table, And we're looking for organs grown from stem cells, which is right here, and HIV identified, which is right there. So I'm going to erase my purple ones just because it's going to be hard to see. Get my pencil back out. So we might say that HIV was around let's see, we're after Tessie Baby. So I might want to say 1985, just compared on my other numbers. And organs grown from stem cells look like they could be as late as 2010 because it's after 2000. So maybe we'll say 2010 for that one. So the first thing that happened was that HIV was identified. So this was first. We said that happened about 1985. And stem cells, organs grown from stem cells was probably around 2010. And again, it's just an estimate. You're just estimating from how it'll read on the timeline. At the top of page 217, they give us a nice table of how to compare numbers. These are some symbols you've probably seen somewhere in mathematics before. First one is equals. The second one is approximately equal to. The equal sign with a line through it means not equal to. Then you see less than or equal to, greater than or equal to. So take some time to look through that box and make sure you understand the symbols. And they're going to have us go back and do a couple problems we did. So they want us to look at our numbers from number 12. We had 1980 and 1970 in number 12. So I'm going to come write those again. We had 1980 and 1970. And the reason I switched the order is because they want me to use a less than sign. So I would say that 1970 is less than or before 1980. And then 15 wants me to use my numbers from 13 with a greater than symbol. So 13, my numbers were 2010 and 1985. Let's get our pink pen back out. We had 2010 and 1985. And they did ask me to use a greater than symbol. 2010 is greater than 1985. Or comes before, or comes later, sorry. The two most recent events on the timeline are organs grown from stem cells and skin cells grown into stem cells. So let's go back and look at our table and see how those might compare. I'm going to erase again some of the stuff I have on here, just because it makes it hard to see. And let's get a different color out here. So we have these last two that we're looking at right here. Well, if you look at the table, it's really hard to say which one came first. So it looks like they could almost have happened at the same year. So it says, how do the dates compare? We're going to say pretty close, maybe the same. Pretty close. Maybe same year. We'd have to go into some more detail to find out more information. So that's number 16. Number 17, which is on the top of page 218, says, well, maybe we can use the less than or equal to or greater than or equal to sign then, because we could compare them that way. So we could say that comparing organs and stem cells could be less than or equal to. We could have also written it the other way, greater than or equal to, because we think they are pretty close. So one might be slightly before or slightly after, but we can definitely use that inequality to part two to include the possibility that they're the same year. Got some nice verbal descriptions here in the purple box on page 218 of inequality symbols. And then as you go to approach your group work, you're going to be doing some stuff with that relative change percent error. That'll be popping up again, and you'll definitely be doing a little more with estimation. And I hope you enjoy your group work on this section.